Imagine you could step outside the universe. Imagine you found yourself in a Platissoan control room. On the walls, you see thousands of dials. Each dial represents a fundamental law of nature: the weight of an electron, the speed of light, the strength of gravity. Currently, they are set to very specific numbers. Now, imagine you reach out and turn one of those dials, just a fraction, a single notch to the right. The stars go out, the atoms dissolve, the universe collapses into a black hole. You try to turn it back to the left. The universe flies apart so fast that light can never reach matter. This is the Mach fine-tuning problem. We do not live in a random chaotic void. We live in a machine that has been calibrated to an impossible precision. Let us look at the beginning, the Big Bang. It was not just an explosion, it was a surgical strike. If the expansion rate of the early universe had been different by 1 part in a million, we would not be here. If it was slightly faster, gravity would never have been able to pull atoms together. No stars, no galaxies, just cold, lonely dust forever. If it was slightly slower, gravity would have won instantly. The universe would have crunched back down into a fireball before life ever began. We are walking on a knife's edge. To the left is ice, to the right is fire. And we have been walking this line for 13.8 billion years without falling. How likely is this? How lucky are we? The physicist Roger Penrose calculated the odds of our universe having the specific low entropy conditions necessary for life. The number is 10 to the power of 10 to the power of 123. There are not enough atoms in the entire cosmos to even write that number down. It is the mathematical equivalent of throwing a dart across the entire observable universe and hitting a target the size of a single proton. This is not luck. This is suspicious. It looks like a setup. The machinery of our reality is built on 4 pillars. There are 4 fundamental forces: gravity, electromagnetism, the strong nuclear force, and the weak nuclear force. Their relationships are baffling. If the strong force, the glue that holds atomic nuclei together, were just 2% stronger, hydrogen would fuse instantly. The sun would explode in seconds. If it were 2% weaker, atoms could not hold together. There would be no chemistry, no water, no you. The dials are set to the precise Goldilocks zone where stable matter is possible. Consider gravity. It is the force that shapes the cosmos, yet it is shockingly weak. Think about a fridge magnet. That tiny magnet can lift a paperclip against the gravitational pull of the entire Earth. Electromagnetism is 10 to the power of 36 times stronger than gravity. This weakness is not a bug, it is a feature. If gravity were stronger, stars would burn their fuel too fast. Instead of burning for billions of years, allowing life to evolve, our sun would have burned out in a few thousand years. Gravity is weak, so that life has time to breathe. But the strangest coincidence is inside your own body. Carbon. You are a carbon-based life form, but carbon is incredibly hard to make. It requires 3 helium nuclei to collide at the exact same moment inside a star. Statistically, this should almost never happen, but in the 1950s, physicist Fred Hoyle discovered a resonance, a secret energy doorway that makes the process easy. Hoyle was an atheist, but this shook him. He later wrote, "A common-sense interpretation of the facts suggests that a super-intellect has monkeyed with physics. We are made of impossible ash." Then there is the dark heart of the cosmos, lambda, the cosmological constant, the energy of empty space. Quantum field theory predicts this energy should be massive. But when we measure the actual expansion of the universe, the number is tiny. It is 120 orders of magnitude, smaller than theory predicts. This is the most precise fine-tuning in all of science. If lambda were slightly larger, the universe would have ripped itself apart before the first galaxy formed. It is tuned to 120 decimal places. To call this a coincidence requires a leap of faith larger than any religion. Finally, look at the particles themselves. The electron, the proton, the neutron. The neutron is just slightly heavier than the proton. If it were the other way around, protons would decay into neutrons. Atoms would dissolve. The universe would be a sea of neutral particles. No chemistry, no stars, just a fog. The masses of these particles seem arbitrary, random numbers, and yet they form a perfect chord, a chord that allows the symphony of existence to play. Let us play God. Let us see what happens when we change the settings. Physicists have run computer simulations where they alter the constants of nature. They create virtual universes to see if life can survive in them. The results are disturbing. Almost every single variation results in a sterile, dead wasteland. The universe is not robust, it is fragile. Scenario 1. We turn up the Mach strong nuclear force by just 2%. In our universe, protons repel each other. They wait to fuse inside stars. But with a 2% increase, the protons bond instantly during the Big Bang. All the hydrogen in the cosmos burns up in the first few minutes. There is no hydrogen left to form water. There is no hydrogen left to fuel long-burning stars. The universe becomes a graveyard of helium, a flash in the pan. Life never gets a chance to start. Scenario 2, we turn up gravity. If gravity were just slightly stronger, the expansion of the Big Bang could not escape the pull of matter. Instead of galaxies forming, the universe creates black holes everywhere. Stars would be crushed before they could ignite. Planets would be swallowed. The universe would collapse back on itself in a big crunch shortly after it began. It would be a womb that became a tomb. Scenario 3, we increase dark energy. If the expansion force is too strong, gravity loses the war. Matter is ripped apart faster than it can clump together. Galaxies cannot form. Stars cannot condense. Eventually, the expansion becomes so fast that it rips atoms themselves apart. It is a universe of total isolation, a soup of lonely particles screaming into an ever-widening void, never to touch another. It is not just the forces, it is the multi dimensions. We live in 3 dimensions of space and 1 of time. In a 2D universe, life is impossible. If you have a digestive tract, a tube from mouth to exit, it would cut your body in half. You would fall apart. In a 4D universe, gravity behaves differently. Planetary orbits become unstable. Earth would eventually spiral into the sun or be flung out into the cold. 3 dimensions is the only structure that allows for stable orbits and complex biology. We are trapped in the only room in the house where life can breathe. So why are we here? Why did the dart hit the target? The most common answer from science is a tautology. The Anthropic Principle. It states, we observe these values because if they were different, we wouldn't be here to observe them. Imagine you survive a firing squad. 50 sharpshooters aim at you. They all miss. Do you say, wow, what a lucky coincidence? Or do you demand an explanation? The Anthropic Principle says you shouldn't be surprised, because if they hadn't, missed you wouldn't be asking the question. It is logical, but it feels unsatisfying. Douglas Adams mocked this arrogance with his famous white puddle analogy. Imagine a puddle waking up one morning. It looks at the hole it fills and thinks, this hole fits me perfectly. It has my exact curves. It must have been built for me. The puddle doesn't realize that it changed shape to fit the hole. Perhaps we are the same. The universe wasn't tuned for us. We evolved to fit the universe. If gravity were stronger, maybe we would be short, squat creatures made of silicon. We would still think the universe was perfect. But there is another solution, one that saves us from the need for a creator. The multiverse. If you roll a dice once, rolling a 6 is luck. If you roll a dice a billion times, rolling a 6 is inevitable. Maybe our universe is just one bubble in an infinite foam. Maybe there are trillions of failed universes out there, the hydrogen universes, the dark universes where no one exists to complain. We are simply the winners of a cosmic lottery. Not because we are special, but because we are the only ones left holding a ticket. And yet, even the multiverse theory is a guess. We have no proof other bubbles exist. We only have this one. And when you look at the equations, they do not look messy. They look elegant. E equals mc squared. F equals May. Simple, beautiful, symmetrical. The universe does not look like a random accident. It looks like a work of art. And art implies an artist. Whether that artist is a god or a programmer running a simulation, the feeling of intent is hard to shake. Max Tegmark, a cosmologist at MIT, suggests an even stranger idea. The universe isn't described by math. The universe is math. An electron is not a physical ball. It is a mathematical field. Gravity is geometry. Reality is just a structure of numbers. We are characters living inside a complex equation, and we have just started to read the source code. So what is the answer? Are we one of infinite bubbles, or are we a solitary miracle? Science cannot tell us yet, but the result is the same. Whatever the mechanism you are holding, the random winning ticket, out of the chaos of the Big Bang, the laws of physics aligned perfectly to allow you to exist, to allow you to think, to allow you to feel the sun on your face. The odds against you were astronomical. The universe had trillions of ways to be dead, and yet, here you are. Do not take this reality for granted. Every breath you take is a statistical impossibility. Every heartbeat is a victory over the void. The universe is playing a symphony. It is played on a razor's edge tuned to a perfection we can barely comprehend. And for this brief moment in eternity, you are the music. Listen closely.